Please note, the reading of the interpretive brochure may not coincide with the photos seen in the video at the same point of time. Welcome to Toadstool Geologic Park. The stark, otherworldly landscape you are about to explore is like no other place in Nebraska. Yet its barren hills and rock-strewn gullies disguise the abundant life it once supported. Turn the clock back 30 million years and you would find miniature horses, humpless camels, gigantic tortoises, pigs, and even rhinoceroses roaming here. All that remains of these bizarre beasts are bits of bone and tracks imprinted in the once soft mud. Scientists have pieced these clues together to capture what life was like in this ancient river valley millions of years ago. A river ran through it. It was hot and muggy when these prehistoric mammals came to drink on the shores of this broad, shallow river. The water current carried volcanic debris that, layer upon layer, formed the rocks you see today. Over time, water and wind sculpted the rock into badlands. These geologic processes preserved, and erosion exposed the record of North America's early Great Plains animals. Follow the trail markers along the mile-long loop trail to unravel the park's mysteries. The first 1/4 mile of trail is universally accessible. Beyond that, the trail winds along stream beds, through gullies, and over sandstone rock. Toadstools and trackways await your discovery. Why is it called Toadstool? The first visitors here in the late 1800s must have felt they were traveling through a land of giant mushrooms. They fancifully labeled the jumble of sandstone slabs resting upon their clay pillars, toadstools. The name stuck. Toadstools are created by the forces of wind and water, eroding the soft clay faster than the hard sandstone rock that caps it. Erosion eventually collapses the giant toadstools while new ones are forming. Travel over gravel. Volcanoes to the west periodically blanketed this area with ash. Water from rain and snow dissolved the ash and seeped into cracks in the clay, where it crystallized. The width of the cracks is the thickness of the gravel pieces. As clay eroded, the hardened minerals and bone fragments of long-dead animals became exposed. Notice the dark, jagged gravel beneath your feet. This desert pavement is a coarse mixture of silicon dioxide, the same compound as glass, and fossil bone fragments. Pocks in the rocks? No, they're tracks. Tracks are distinguished from other depressions in the rock because they do not occur randomly. These were made by animals living about 30 million years ago. The toes point in the direction of travel. The size and depth of the tracks indicate the size and weight of the animal that made them. The stride is the distance between tracks made by the same foot. Changes in travel speed are shown by lengthened or shortened strides. Compare the photograph to the large rock off to your right. Can you see the tracks of a four-legged animal as it made its way across the mud, now hardened to stone? Close inspection of the tracks shows the foot had 2 toes. Its size and shape are consistent with the entelodonts, giant pigs, of the time. Keep looking. You may see other tracks. Water's cutting edge. Over time, rushing water has cut away the underside of this cliff. When the bank is undercut enough, the weight of the overhead mass breaks off in large chunks, crashing into the stream bed and diverting the stream flows. These badlands erode away at an average of an inch per year. How much change has occurred since you were born? Seasonal flooding filled prehistoric tracks with mud and silt, preserving them. What tracks will you leave for future visitors to discover? Whose fault is it? Well, no one's really. A geologic fault occurs when underground stresses cause the Earth's crust to fracture. Small shifts may go unnoticed, while large movements cause major earthquakes. Rock layers and colors abruptly change at the fault line. Looking west across the drain age, notice the horizontal band of rocks in the cliff face. The band ends suddenly, then continues on approximately 30 feet lower. Could you have felt this shift that occurred between 8 and 2 million years ago? 6. Cliff clues. As the rock cliff is undercut by erosion, overhanging rocks break off. When will the next break occur? Since no one can predict this, please view the cliff from a safe distance. Toadstool Geological Park and Campground. Missing pages. Toadstool Geologic Park is a key link in understanding the Earth's history from 38 to 24 million years ago. Geologists consider it the type section for the White River Group, meaning that all other similar aged deposits in North America are compared to the geologic standard designated at Toadstool. It is also the standard for animal fossils of that age, the Eocene and Oligocene epochs about 30 million years ago. Like tearing pages from a book, Removing parts of the fossil record destroys the information it could yield to scientists. When bones or tracks are disturbed, they lose scientific value and become mere curiosities. 7. Prehistoric pictures. By now you've noticed two kinds of rock, a light buff-colored claystone and a darker sandstone. The claystone is softer than the sandstone. The sandstone was formed as a sandbar in the river that flowed 30 million years ago. Wildlife attracted to the water left their tracks in the wet sand, some of which were preserved and are now visible today. In the photo are webbed tracks left by prehistoric ducks. Can you picture them sunning, preening, and dabbling for food on the shore millions of years ago? Unfortunately, these tracks were vandalized, destroying information about the animals that left them. Back to basics, these terms of the trade will help you understand your prehistoric journey through Toadstool. Badlands refers to rugged arid lands with heavy clay soils that are eroded by wind and water. Deposition, the result of volcanic and sedimentary processes that result in a building process accumulating sediments. Erosion, a geological process of removing, wearing away and redistributing dust, rock and soil particles. Paleontology, the study of prehistoric life and processes. Titanothere, a large distant relative of rhinoceros that browsed on trees and shrubs. The discovery of its large bones gave rise to legends of the thunder horse. Trackway, preserved animal tracks. Toadstool, a sandstone slab resting on a clay pedestal, resembling a mushroom. Fracture, or break in the rock. Fault, displacement of rock layers due to fracturing. Fossils, the remains or traces of prehistoric plant or animal life have been preserved by natural processes. The Forest Service wishes to thank the University of Nebraska Trailside Museum for their technical assistance. If you have not subscribed to the channel yet, please hit the subscribe button below. Thank you.